Hey, everybody. How are you today? All right, let me change this. Video. All right, there we go. It's great to see everyone today. You all doing well? Yeah, good. Wonderful. Wonderful. Can't tell if it's AC or a fish that we have in class today. Kind of going in and out there, AC. All right. Do any of you have any questions? Anything you want to ask about or talk about? No? All right. When we will begin. Hold on just a second here. All right. Can you see that where it says physical science? Yes. Wonderful. Wonderful. All right. So what we are going to do today is we're going to start, I hope, talking about carbon chemistry. Whoop. Nope. Nope. There we go. Zooming past everything. So yesterday, or the day before, you guys started learning about carbon chemistry. And there really isn't a lot that's more important to living things than carbon. Maybe water, but we are made of carbon. A lot of us is carbon. Carbon has been called the backbone of life. And the reason for that is because life on Earth just wouldn't be possible without carbon. So you're going to learn why carbon is so important. So I want to introduce carbon chemistry, talk a little bit about it. But first, before we do that, I want to do a Jeopardy game for a review. All right, now we're missing a couple students, so I'm going to rearrange things here. And if they join us, then, we'll add them into one of the classes. So let me see here. We have Isa. We have, let's do, okay, we'll do it this way. So we have AC, Allison, and Bella is not here. So we'll put AC, Allison, and Nyla on one team, and then Muhammad and Nyla. Nope, got Nyla on the other one. All right, hold on. We have 1, 2, 3, 4, 5 students. We need 1, 2. All right, so this is how we're going to do it. We are, oh, here comes Cheyenne. That's helpful. Okay, so let me share my here with you. Okay, and here comes Wick. So we will put Wick on team 1. And so we have 1, 2, 3, 4, 5, 6, 7 students. 1, 2, 3, 4, 5, 6, 7. Okay, so this is how we're going to do our teams. And if you guys have never seen, go ahead, Wick.
Yeah, my camera's not working because
Okay.
I'm going to get my manual camera.
That's fine. If you want to get your camera, you can, but I recognize your voice, so that works as your verification for this week. And hopefully you'll get your camera back next week. Okay. All right. So we are, like I said, we're going to play this game, this Jeopardy game, to review basically everything that we've done so far, some of the important things that we've learned about so far. So we've got AC, Allison, Nyla, and Wick on team 1, Muhammad, Isa, and Cheyenne on team 2, and then I'll be team 3. So if nobody can answer one of the questions, nobody on your team can answer, then I get the point. All right. So you guys are going to take turns choosing a category and a point value, but anybody on your team can answer. So, for example, when we'll start with AC. So AC will pick whichever one of these AC wants, and then AC, Allison, Nyla, and Wick can all 3 answer. So we'll give the person who calls out the category the first shot at it. But AC could say, I would like my team to help. If you're just not quite sure of the answer, you want some validation from your team, you say, I would like my team to help. And then anybody on that team can answer. If nobody on that team can answer, then I get the points. If you can answer, then you get the points. Okay, you understand how to play now? So we'll go back and forth. We'll do AC, Muhammad, Allison, Isa, Nyla, Cheyenne, Wick, Muhammad, and then back to the beginning again. And if anybody else comes in, oh, there's Bella. All right, awesome. So Bella's here. So let me put Bella here. All right, so Bella will be on team 2. So team 1, team 2, and team 3. All right, anybody have any questions? All right, so we're going to start with AC. So AC, you pick your category and the point value.
I pick periodic table 300.
Periodic table for 300. What are the 3 categories of elements on the periodic table? So AC gets a chance. If AC wants help, he'll let you know. Go ahead,
I
AC.
should have picked 500. Metals, non-metals, metal, non-metal, and oh my god, why am I not remembering this? Metal, non-metal, and
I
metalloid.
can help.
There you go. There you go.
Yeah,
Excellent.
get it.
Excellent. All right. Don't yell out. You got to give your team member a chance to get it first. And then if the team member says, I would like some help, then you give the help, and don't type it into the chat box either. Okay. Oh, okay. All right. I guess. Okay. Hold on just a second. All right. So yes, you are correct. The metals are the most prevalent group. They're the blue purple color here. There are more metals than anything else. Then the green are the metals, non-metals, and then these stair-step ones in the middle are the metalloids. Excellent. All right, team 1 gets 300 points. Now we go to team 2, and we will do Muhammad. You get the first pick. All right, there we go. Muhammad, you tell me the category and the point value.
States of matter, 400.
400. What state of matter lacks a fixed volume and fixed shape and consists of charged particles? All right, Muhammad, you get a chance to answer first. If you would like your team to help, just say, I would like my team to help. You're muted, Muhammad. I can't tell if you're talking or not.
I'm thinking.
Okay. What state of matter lacks a fixed volume and fixed shape and consists of charged particles?
Plasma?
Very good. It is plasma. Excellent. So there's examples of plasma: lightning, solar wind, auroras. Did any of you guys live where about a week ago you got to see the auroras? I'm not sure. Well, hold on just a second. I have a student who's not able to hear me. Hold on one second. Okay. See if we can hear other students. Okay. Okay, I'm gonna have to keep on going here. Hopefully Isa can get the speakers working. Okay, so did anybody live where you got to see the auroras a couple of days ago? So remember what happens with an aurora is we've got this magnetic sphere around the outside of the earth. It is a protection for the earth from solar wind. So when energy from the sun hits that magnetosphere, it's directed around. Well, sometimes there's a big solar storm, and that's what we had. A big wave of energy came from the sun, and the way it interacts with our atmosphere because of the magnetic sphere around the earth, it creates these beautiful colors. And a lot of people saw those. I did not, unfortunately. They were in my area, but I kept going outside looking for them. I was very disappointed. I didn't see them. All right, so that is team 2. All right, next we go to Allison.
I do Periodic table 200.
Periodic table for 200. What do we call the columns, the up and down ones on the periodic table? If you're not quite sure, you can ask your teammates for, to verify.
Magnitudes.
Okay. All right, Wick.
Groups.
Yeah,
Okay.
I would say the same.
Okay. All right. AC verifies that. Groups,
Me
or
too.
what else are they called? Groups, or what else?
Family.
AC.
Yeah, family.
Yeah, they are called groups or families. So either one of those would have been accepted. All right, excellent. Team one gets another couple hundred points. Now we are to Isa. Are you able to hear me? I guess not. All right, we're gonna have to skip Isa and we will go to Cheyenne. Cheyenne, pick a category and a point value.
States of matter 500.
States of matter 500. Remember, you guys have to have your cameras on unless your parents have let me know that you have a camera problem. All right, there we go. List the 4 states of matter and tell which is rarely found on Earth. All right, Cheyenne, you can either answer or you can ask your team for help.
So easy. Periodic table
Cheyenne, are you there? I don't know if we're losing connection here. All right, Cheyenne typed the answer. Liquid, solid, plasma, gas, plasma is rare on Earth. You got it. That's the correct answer. The most common states of matter on Earth are solid, liquid, and gas. All right, so that was Cheyenne. Now we are back to Nyla.
I think atomic structure 400.
Atomic structure. Did you say 400 or 400?
I said 400.
Okay, it's always hard for me to tell if students are saying 400 or 400. All right, there we go. All right, Nyla, what do we call the electrons in the outermost energy shell?
Valence electrons.
Yeah,
I know.
very good. They are valence electrons. All right, great job. Now we are to team 2 and Bella. All right, Bella, are you with us?
Periodic table 500.
All right, Bella, I'm going to give you a count to 5 to pick a category, and then I'm going to go on to somebody else. 5, 4, 3, 2, 1. All right, so we are going to go back to Mohammed. All right, Mohammed, pick a category and a point value.
Physical and chemical change 500.
Physical and chemical change 500. Yeah, that's fine. That's fine. What is the law of conservation of mass?
I know this.
This is Mohammed. All right.
Mass in and wait, let me think.
Don't say it, AC.
Mass that is like isolated and like a system that's not created or destroyed by
There
chemical
you
reaction.
go. That's the words I was looking for. Mass is not created or destroyed. Exactly. That's what it is. What we call the law of conservation of mass. All right. Mohammed gets more points for his team. And next we had Nyla last. Wick, your turn.
Periodic table 500.
Periodic table 500. What are the last 2 groups on the periodic table?
Okay. The last one is noble gases.
So anyway, the bottom line here that I want to make sure.
Okay, I need help from my team for the second one.
All right. Team, you want to help out?
The second to last ones are halogens.
All right, very good. Halogens are the next to the last right here, and noble gases are the last one. All right, so that is 500 more points for team one. All right, and next we have Isa. Isa, can you hear me now? I think Isa's having trouble being able to hear. All right, so we will go to Cheyenne.
Atomic structure 500.
Sorry, that was real staticky. Say it again.
Atomic structure 500.
Atomic structure 500. What must happen for an electron to jump to a different energy level?
The electron has to gain energy.
Yep, it has to gain energy or,
Or lose energy.
yeah, exactly. It has to gain energy to jump to a higher level. It has to lose energy to jump to a lower level. All right, so that was Cheyenne for 500. Now we are back to AC.
Phase changes 500.
Phase changes 500. What is the process in which a gas changes to a solid without going through the liquid state? Hey, you got to work for the 500s. I made them
Is
harder.
anyone now?
What?
I was asking my team if anyone else knows.
Okay, team, you want to
I
help
think
them
it's sublimation, or is that the opposite?
out? You got to come to an agreement.
Smacking into each other.
AC, Allison, Nyla, and Wick.
Deposition or
Deplimation, deplization.
I,
think.
I,
I'm going to accept that. That's close enough. It's deposition. Deposition, not deposition. There's no L in there, but yeah, we'll accept that. That is close enough. All right, very well done. All right, next we are to Bella. So Bella, are you with us yet? I don't know if Bella can't hear. All right, so we will go back to Muhammad.
Atomic structure 200.
Atomic structure 200. Electrons at different energy levels have different amounts of energy. Where do you find electrons with the least amount of energy?
With the
What do you
least
think? Sorry, say again.
with the least amount.
Yeah, with the least amount of energy. Remember, we have those electron shells. Which one has the least amount of energy?
Am I allowed to get a hint?
You want to help out, Cheyenne?
Yes. The place where you'd find electron has the least amount of energy is the first energy ring, because it's the protons and the neutron that are holding that are keeping the electrons close.
Yeah.
And to overcome the force of attraction between the protons and electrons, and an electron needs to have more energy to
Yep.
stay farther away from the
To get farther from that nucleus. Yeah, very good. Excellent answer. That is the correct answer, closest to the nucleus. So the way I like to remember that is I think of electrons as being kind of homesick, and they like to be real close to home. It takes way less energy to be at home, doesn't it? When you're at home, you can relax, you can put your feet up, you can be a couch potato, but the farther you get from home, the more energy it takes, right? All right, so that was team 2. And we are back now to team 1, and that will be Wick was last. So AC.
I think I just went. I think I was the last on my team to go.
Oh, you were? I'm sorry, I didn't write that down then. All right, so Allison.
Can I do states of matter 300?
States of matter for 300. What state of matter has no definite shape and no definite volume?
Isn't it gas?
It is
Thank you.
gas. Excellent job. It is a gas, like the air we breathe, goes everywhere. No definite shape, no definite volume. All right, that was Allison for 300. And next we have Muhammad was last. Isa, can you hear me yet? Still no. All right, Cheyenne. Looks like Muhammad and Cheyenne are having to carry the load this time.
Chemical interactions, part 1, 500.
Chemical interactions, part 1, 500. What goes here?
Product.
Yeah, that's it. Reactants yield products. Very good. All right, so that was team 2. And I'm kind of losing track here because of the missing. So that was Cheyenne. And we had Muhammad last. Oh no, so we had Allison last, Nyla.
Chemical interactions, 500.
All right. When is a chemical equation balanced?
I think I need some help.
Okay. AC.
I think it's when they're the same amount of atoms on each side of the equation.
Yep, that's it. That's exactly right. When you have the same number of all of the elements on both sides of the equation. Excellent. All right, so that is 500 more points. All right, maybe you guys should tell me who's next. You guys are doing a better job keeping track. So that was Nyla, and now we had Cheyenne last, so we're going to go to Muhammad next.
Phase changes 400.
Phase changes 400. What is the process in which a liquid changes to a gas without becoming hot enough to boil? A liquid changes to a gas without becoming hot enough to boil. Muhammad, you want some help from Cheyenne?
No, I'm fine. I'm just thinking.
Okay.
Evaporation.
I heard enough of that to know that you got the correct answer. Well, I just heard evap, but that's enough. Evaporation. Yeah, very important part of the water cycle. All right, now Nyla was last, so now we have Wick.
Okay, periodic table 400.
Periodic table for 400. What are the first two groups on the periodic table called?
Alkali earth metals and alkaline metals.
Very good. Oops, darn it. I keep doing that. All right, let me see here. There we go. They are alkali and alkaline earth metals. The first one are the alkalis. The second are the alkaline earths. Very good. Look at this, guys. Really close score. I love this. All right, so Muhammad was last. Cheyenne, you are next.
Physical and chemical changes 400.
What do we call the ability of matter to combine chemically with other substances?
Reactivity.
Yeah, very good. It is reactivity. Excellent. All right, so that was team 2. Now, AC.
Chemical interactions, part 1, 400.
400. What do we call bonds between atoms that do not share electrons equally?
I just did this in my test, I should know.
It's when you're put on the spot that those things drop right out of your head. They do not share.
Wick, is it polar?
Yes, polar
Polar bonds.
Polar what?
Polar covalent bonds.
Yeah, that's it. Polar covalent bonds. Remember, they're covalent because they're sharing. They're cooperating with their valence electrons. So they're sharing those electrons, but one of them's pulling harder. So they're polar. They're called polar because they that pulling makes this one a little bit more negative and this one a little bit more positive. That's what we call having poles. Kind of like the North Pole and the South Pole. They have a positive pole and a negative pole. So excellent job. All right. Now, all right, who went last? Cheyenne or Mohammed? It was Mohammed. Cheyenne, you're next.
It's me who went last.
Say it again.
It's Muhammad's turn now. I went last.
Oh, okay, Mohammed, your turn then.
Chemical interactions, part 2, 400.
A reaction in which a fuel reacts quickly with oxygen and produces carbon dioxide and water is called a fuel and oxygen yield carbon dioxide and water.
Combustion reaction.
Very good. It is a combustion reaction. Anytime you light a match or make a fire, you are creating a combustion reaction. Excellent. All right. Now, last was AC. So, Allison.
Can I do states of matter 200?
States of matter 200. What state of matter has a definite volume and takes the shape of its container?
Liquid.
Yeah, it is a liquid. Very good, Allison. All right. So Allison, and we had Mohammed last. Now it's Cheyenne again.
Atomic structure 300.
What do we call the region around the nucleus where electrons are most likely to be? And there's a couple of different possibilities here. Go ahead. Sorry, you're real staticky. Say it again.
And
Can anybody hear what Cheyenne is saying? Why don't you type it in, Cheyenne? Can't tell. Are you typing, Cheyenne? All right. Yeah, very good. That's close enough. An orbital or an orbit. I would also have accepted energy level or energy shell. But yeah, they're these strange shaped orbitals. I think that's just really amazing. And that isn't necessarily where they are. It's where they're likely to be. All right. So there's 300 points for Cheyenne. And next we are to, who did we do last on team 1? Allison. Nyla, your turn.
Physical change 300.
Physical change, 300. What do we call the ability of matter to burn?
It's the can you guys check if this is right? The flammability?
Yeah, that's it. Flammability. Excellent job. Excellent job. All right. Nyla adds to the team. And now we are back to Mohammed.
Phase changes 200.
Phase changes 200. When melting occurs, are the particles gaining or losing energy? What do you think? Gaining or losing?
I think they get.
When melting occurs, they are gaining energy. They get enough energy to overcome the force of attraction holding them together so they can move out of their fixed positions and slip over each other. Very good, Mohammed. Very good. All right. So now we are to Wick.
Chemical interactions, part 1, 300.
What kind of bonds are forces of attraction between positive metal ions and the valence electrons that surround them?
Metallic bonds.
Yeah, that's a metallic. I love metallic bonds. I think it's so cool to picture that, to picture the nuclei just holding still and all the electrons kind of moving around them in this sea of electrons. That is a metallic bond. Excellent job. All right, Cheyenne.
Phase changes 200.
Phase changes how much?
300.
All right. What is the process in which a solid changes directly to a gas without going through the liquid state?
Sublimation.
Very good. That's what happens inside your freezer when the ice cubes seem to just magically get smaller. It is sublimation. All right, that was Cheyenne. So now back to AC.
Chemical interactions, part 2, 300.
Reactions that release more energy than they use are called what? These are the ones we talked about last week. The ones that release more energy than they use.
Wick,
I think it's exothermic.
You think correctly. It is exothermic. Remember, the heat is exiting. It's being released. Exothermic. All right, look at that. Tie game so far. Mohammed.
Chemical interactions, part 1, 200.
What kind of bond forms when a metal transfers valence electrons to a non-metal?
Ionic bond.
Yeah, it is an ionic bond. Very good. It transfers, so it creates two ions. One gave away an electron, so it's more positive. It's now called a cation because I'm positive about cats. The one that gains the electron is now more negative, so it becomes an anion. And now since you have a positive and a negative real close to each other, they stick together. They want to be near one another. All right, excellent job, Mohammed. Now we are to Allison.
Can I do chemical interaction part 2, 200?
A substance that increases the rate of a chemical reaction is called a increases the rate. That means it makes it go faster.
Um,
You can get help from your team if you'd like. That's what
can I
they're there
have
for.
help? Yeah, can I have
I know
that's a
that.
catalyst.
Oh,
Yeah, you got it.
Like, isn't that a catalyst?
Catalyst. A catalyst. Excellent job. All right. 48-48. Team 2. Cheyenne. Not hearing you at all, Cheyenne. Why don't you type it in? Physical and chemical changes. 200. What is defined as anything that has mass or volume? You got it. Matter, matter. Excellent. There's the answer. matter has mass or volume. All right, guys, we're down to just the hundreds now. So Allison was last. Nyla.
States of matter 100.
States of matter 100. What state of matter has a definite shape and a definite volume?
Solid.
That is a solid. Very good. And we'll give you the points. And now Muhammad again.
Physical and chemical changes one.
A change in one or more physical properties of matter without any change in chemical properties is called a what change?
A physical change.
It is a physical change. Very good. Very good. All right. Now Nyla was last. Wick.
Periodic table 100.
Periodic table 100. Oh, wow. That's really tiny. What do we call the rows on the periodic table?
This is the max period. Well, the law of conservation.
The rows go this way.
I help.
They're periods.
Yeah, they are called periods. So remember, the periods go this way. The groups or families go up and down. They're the columns. So good job. Good teamwork. I love that. All right. Let's see. Muhammad Cheyenne, your turn again.
Atomic structure.
Atomic structure. Name the 3 parts of an atom and give their charges.
Electrons, neutrons, and protons. Protons have positive charge. Neutrons are neutral, and electrons have negative charge.
Excellent. That's exactly right. Exactly right. All right. AC.
Phase changes 100.
In what phase change does matter change from a liquid to a solid as its particles lose energy until eventually the particles vibrate in a fixed position and are crowded closely together? What do we call that change, the phase change, where things go from liquid to solid over time?
Well, I feel like this isn't the right answer, but is it freezing?
It
That's
is
what it sounds
freezing.
like.
Yeah, that's exactly freezing. That's what happens. Those particles will keep losing energy until eventually they're an ice cube. Eventually they're so close together and they're just vibrating. All right, great job. Now Cheyenne was last, so Muhammad, you have the last one. And then that's going to be it because each team will have had the same number.
Chemical interactions, part 1.
What kind of bonds form when nonmetals share valence electrons?
Covalent bonds.
It is covalent bonds. Excellent job. All right, look what we did here, guys. Very, very good score. 5,100 for team 1, 5,300 for team 2. That's just about as close as you can get. It's just a matter of the choosing of the numbers. So excellent, excellent job. All right, so team 2, Muhammad and Cheyenne, you guys each get 2 extra credit points. Let me write that down. All right. Let's look at what the last one is, see if anybody can answer that one. The energy needed for a chemical reaction to begin is called, Wick.
Activation energy.
Yeah, it is called activation energy. That's what the catalyst does, is it lowers the activation energy. It makes it so it doesn't take as much energy for a reaction to occur. So the reaction can happen a lot faster. All right, terrific job, everybody. Wick.
Is this kind of what happens when neurons send signals and they send the neurotransmitters?
Give me more detail. What do you mean? Is this what happens?
Like, is this how they increase? Does the neurotransmitter like increase the electricity kind of?
Not exactly. So what you're talking about, what Wick's talking about is like, think of your brain. When a brain sends a message to your body, it sends it through a neuron. It's a cell of the nervous system. Well, while it's moving along the neuron, it's an electrical message. When it gets to the end of a neuron, where one neuron is here, the other neuron is here, there's this space in between the two. That space is a gap. Well, electricity can't move across that gap. A neurotransmitter is a chemical that exists in the gap. So it's released by this neuron and picked up by this one. That's what a neurotransmitter is. It's just the chemical way to move a message from one neuron to another. It's different than a catalyst. Now, there's catalysts involved in a lot of what happens in our body, but it's not what a neurotransmitter is. Yeah, good question, though. All right, anybody have any questions about anything that we just did? Anything that we reviewed? Hopefully that was a helpful review as we move into talking about carbon chemistry. So carbon chemistry is really important because of all the ways, oh, great, wonderful, all the ways that it can bond. So take a look at carbon here on the periodic table. So here's carbon right here. We've blown it up right here, so it's big. So what is the atomic number of carbon? Nyla?
6.
Excellent. What is its atomic mass? Isa? Can't hear you, Isa. Now you can hear us, but we can't hear you. All right, you can type it in the chat box if you want. Wick?
The atomic mass is 12.011.
Yes, excellent. Now remember, and Isa got it too, great. Remember that decimal after there is because there are some isotopes of carbon. An isotope is when an atom has more neutrons than normal or fewer neutrons than normal. We average all of those isotopes to get the carbons, to get the element's atomic mass number. All right, take a look where carbon is on the periodic table. What group is it in? What group number? Isa? Still not hearing you, Isa.
14.
Wick? Yeah, it is in group 14. What's the name that we give to all the elements in group 14? Wick?
The carbon group?
Yeah, we call them the carbon group. All right, so how many valence electrons does carbon have? Remember, we can tell valence electrons. Good, Cheyenne, it's got 4. We can tell valence electrons if we go this way. 1, 2, we kind of skip these because they're, complicated. So 1, 2, 3, 4, 5, 6, 7, 8. You can also remember counting backwards because noble gases have 8. They're happy. They have as many as they want. Then you can count backwards. 7, 6, 5, 4. So carbon has 4 valence electrons. How many does it want to have? Hold your fingers up. Yeah, it wants to have 8. Exactly. That's the octet rule. I want 8. All atoms want to have 8 in their outside energy shell. So if it has 4, but it wants 8, how many bonds can it form? Show of fingers. 4. It can hold 4. So you can think of carbon this way. Think of it as an atom that has 4 arms, and each one of those arms really wants to be holding hands with another atom, right? So it wants to have 4 friends that it can hold hands with. It can form up to 4 bonds. Wick, do you have a question? Okay, your hand was up. All right, now we learned about these bonds. We learned that there are 3 main kinds of bonds. The first kind of bond that we learned about is the ionic bond. This is where one atom gives an electron away to another atom. They're now ions. They're now a cation and an anion, and they stick together. This happens when a metal donates to a non-metal. The next kind we learned about is covalent. Remember, valent refers to the valence electrons. Think cooperate. So they're cooperating with their valence electrons. They're sharing with one another. These are two non-metals, and they share their valence electrons. And then we talked about metallic. That's where those electrons just move freely around the outside of the atoms. We also talked about hydrogen bonds. Hydrogen bonds are a little bit different than these three main ones because, first of all, they're not as strong. Hydrogen bonds are pretty easy to break. But a hydrogen bond is a force between molecules, where these three main bonds, they're a force between atoms. So hydrogen bonds are really important. They're very important in water, in getting water molecules to separate from one another. And they're also pretty important in proteins and DNA, which is our genetic material. So hydrogen bonds are important, but they're not one of the three major kinds of chemical bonds between atoms. All right, so what kind of bond does carbon form? First of all, look where it is. What kind of bond does carbon form? There's the three. Which one of those three does it form? Mostly. Well, only. Isa.
Covalent?
It forms covalent bonds, only covalent bonds. Remember, the carbon group has 4 valence electrons. They don't want to give away all 4. That would take a lot of energy. And they don't want to gain 4. That would take a lot of energy too. They want to share. And that's what they do in a covalent bond. Now, this ability to form covalent bonds with 4 other elements lets carbon form really huge long chains that are almost unlimited in length. So carbon can bond with other carbons. It can bond with other elements. It can form straight chains like we see here. It can form branch chains like we see here. It can even form rings. Carbon will always want to make 4 bonds with other different kinds of atoms. Oh, sorry. So carbon can also form single, double, and triple bonds. So this carbon is happy. It made a double bond with this other carbon. This one is happy because it made a triple bond. It's still got 4 bonds. It's still sharing those 4 valence electrons. It just wants to do what it has to in order to have that octet, to have that full valence shell. So this is a straight chain right here. Now there should be, you know what? Give me 1 second here, everybody. What page are we on here? We're on slide 12. This is wrong. This picture is too big. No, that didn't help either. All right. So there's supposed to be a C here. I'm going to draw them in. There's supposed to be, I don't know why that didn't turn out. There's supposed to be a C here and a C here. Okay, so take a look at this long chain. This is a straight chain. What is the chemical formula for this molecule? Where our chemical formula is? Well, first of all, we can see C's and we can see H's. But how many C's are there? Quick.
There are 6 C's.
I'm sorry, guys, I'm sorry. I got myself confused here. So we're going to erase that. This is not supposed to be a C. This is an H. I don't know why that when I put this on here, I don't know why it cut that off, but those are supposed to be hydrogens. So let me draw the H's here. H, H. That's what that's supposed to be. So now it is C4, H. What? Quick.
6. And I have a question. Is this
Not
weekly?
6.
Wait, wait. Oopsies, that's 10.
C4H10, which is butane. So there's
Oh.
a picture of it right there. Yep, Cheyenne, you got it. Butane is what you would use in a lighter, like the kind of lighter that lights up your grill. If you have a gas grill, you have that lighter that you flick, that's got butane in it. So what's your question, Wick?
I was just asking if this was butane since it had 4.
Yeah, yeah, it is butane. Here's another one that is a branch chain. So here's the branch right down here. This part is the branch right there. Now this is C, these are supposed to be H's right here. Again, they were cut off. This is hexane. So hexane is used to get oil out of seeds. Like if you ever see corn oil or sunflower seed oil, they use hexane to get the oil out. It's also used to make things that smell, fragrances like perfume and air fresheners and flavors that you might see in food. If you see artificial flavor in food, it might be because hexane has some, is used to make flavors. And then here's a ring. I told you guys about that carbon ring. So the formula for this one is going to be there's 1, 2, 3, 4, 5, 6. We're going to have C6 and then H, how many? AC.
Six.
Yep, C6H6 is benzene. So benzene is used to make plastic. It's used to make rubber, dyes, some detergents to make those. So benzene. So those are the 3 different ways that carbon can bond. And carbon is able to, well, carbon is so we call it carbon chemistry in our class. We could also call it organic chemistry because carbon chemistry and organic chemistry are the same thing. In order to be called organic, something has to have carbon in it, at least one. And it's able to form millions of different compounds. And that's what makes life possible on our planet. All right, we are just about out of time. Wick, I saw your hand. Did you have a question or a comment? No. Did somebody? I thought I saw a hand up. No. All right. I think that we are going to stop there because I don't want to get right into anything else for now. So we will do a little bit more next week. Anybody have any questions? You guys did a terrific job with the review. I didn't get any points. There wasn't one question that the team didn't know. Isa.
It's from my homework.
Okay.
So yesterday when I was doing the science quiz, I got a point wrong because I put a capital. So so can I still get the point?
So write to me through Canvas inbox and let me know what the name of the quiz is and which question number it is. I let you do that one time. From now on, after you get one time, grammar counts. So we don't capitalize words in the middle of a sentence unless they're a proper noun. So that's what I mean when I say grammar counts. So one time I will let you get that point back. But now, from now on, you have to make sure that you don't use a capital letter if one isn't needed. That's an important thing to learn to use grammar correctly. So that's why I do it that way. But I understand that it can be hard to kind of get used to thinking that way. So I do give you one. Yeah. All right. Nyla.
I have to go to another class.
Okay, we're done. So you go ahead. All right. Thanks for coming, everybody. Thanks for doing such a great job. And I will see you again next week.
Thank you.
Bye.
Bye.
Bye. Thank
Thanks
you.
for coming.